Today we're going to show you a second way to solve systems. This method is called substitution. So there's actually two substitutions that happen throughout this method, and I think the biggest thing is that you keep yourself very organized. You show all of your work to make sure you pick up positives and negatives and get everything completely put together correctly, and that you keep yourself neat and give yourselves plenty of room to work. So here are the steps. Number one, solve one of the equations for either one of the variables. So it could be that you solve one of them for x equals, or you solve one of them for y equals. But the very first step is to get one of the equations, x equals or y equals. Then on step two, you're going to substitute. So here's the first substitution. The expression, and we'll talk about this in a minute, from step one into the other equation and solve for the other variable. Step three is then we do the second substitute the value from step two into one of the original equations and solve for the final variable. Lastly, what you should do in step four, which we're not writing here, you really should kind of check your answer. We know we should come up with an ordered pair, and that ordered pair should be a true solution to both equations. So you should be able to plug in your x and y and have them work for both equations as well. So these are the steps. Let's just kind of see what one of these looks like, because that's actually going to be more important to see how it plays out. So here we have a system. We're going to use the substitution method. So I could clearly graph these. I see that the first one's in y equals mx plus b. The second one is in our standard form, so I could do a graph to see where that solution set is, but we're going to use the second method. So step one says to have one of the variables solved for in one of the equations. Well, this first one is y equals, so that's what we need. So with that in mind, we can go ahead on to step two. So step two talks about plugging in or substituting the expression into the other equation. So basically, because y is equal to negative 2x minus 9, that means that it's the same thing. So because of that, what I can do is take this and plug it into the other equation where I see y's. So what we're going to do is we're going to do 6x minus 5, and we're going to take away the y and plug in the expression that's equal to y, the negative 2x minus 9 equals 19. And what we're going to do here now is create one equation. So because we had two variables in both equations, we're never going to be able to get a number solution. We're never going to get y equals a number or x equals a number because there's the two variables there. But by plugging them into each other, now notice this equation only has x's. There are no more y's. So one of the clues is if you still see x's and y's when you created this first substitution, something didn't go right and you need to kind of go back and look at your work. So from here, I just solve, and I'm looking to get x all by itself. So again, first step here is remember, think your distributive property first. And remember, this is a negative 5 that we're multiplying on the outside. So I'm going to get 6x plus 10x, and then negative 5 times a negative 9 is plus 45 equals negative 19. Then I still want to continue combining like terms to get 16x plus 45 equals negative 19. Now we're solving for x. So we just continue with, now we're down to our two-step. We use our SAD meg, and I get 16x equals negative 64. And then when I divide by 16, then x is now by itself. Looks like a 2, but it's really a 64. So x equals negative 4. That right here is not a negative sign. So now we have the x value. But again, we know we need an x and a y value. So here's the second part of the substitution, and this is the third step. So now I'm going to take this x equals negative 4 over here and pick one of the equations. Well, when I look at these two equations, I would say this one looks easier to work with, so I'm going to use that one. So I'm going to say this is the one that I'm going to use. So negative 2x minus 9. If x equals negative 4, I can plug it in. And now I just use my order of operations to get 8 minus 9, or negative 1. So y equals negative 1 when x's are negative 4. That means my final answer here is negative 4, negative 1. Now, ideally we show a check, ideally we do a check. Just like with the graphing method, we said you should plug it back into C. So I'm going to do one just orally so you can hear it. So negative 1 would fill in here. Negative 4 would fill in there. And then negative 2 times negative 4 is 8 minus 1. That one definitely works. So then when I go here, I would plug in the negative 4 to get 6 times negative 4 is negative 24. I would plug in the negative 1. Negative 5 times negative 1 is plus 5. Negative 24 plus 5 is negative 19. So that would verify that it definitely does work. Definitely worth it. It's to see that that is your answer before you move on to the next one. So example number 2. So again, the very first step says get one of the equations solved for one of the variables. Now here on this one, neither one of them is. So the very first step I have to do is convert one of them to be y equals or x equals. So I'm just going to grab this one right here because I see one y and it's positive. I'm just going to rework this formula. Remember when we did this, you would have added the x from the left side to undo the minus x to get y equals x plus 3. So that's step 1. So if I need to do that, that's how we did that, remember in the past. So I would have taken the adding x to move this one off and move it over, and then it becomes x plus 3. And remember, don't combine that to make it 3x. So then once I have this, then I say, well, y equals this. So I'm going to plug y in to the other equation as x plus 3 wherever I see y's. So now that second equation is now going to become that. We've replaced the y with the x plus 3 because they are the same thing. Then I can combine like terms. I get 4x plus 3 equals negative 1. Subtract 3 from both sides. I get 4x equals negative 4. Divide by 4. X equals negative 1. Again, that's not my final answer. That's just part of my answer. So I'm going to pick the first equation. So we would go with the negative x plus y equals 3. Now notice I didn't use the second one that we switched. I'm not using this one, which is the same thing, just in case I made a mistake and somehow I rewrote it wrong. We want to use the original ones. So then notice here, so the negative is going to go in. X, we said was 1, a negative 1, so we want to make sure we include the two negatives to get this. So it's really important that x is worth negative 1. It's a negative x, so a negative 1 is a positive 1. And y equals 2. So I believe, again, we want to check this just to make sure. We have an answer of negative 1, 2. So let's check it. So if I plug it in here, I put -1 in to get 1 plus 2 is 3. That one works. If I put a 1 in here, I get 3 times -1 is -3. The 2 goes in here. -3 plus 2 is -1. So that would prove that I do have the right answer. And the answer would be the -1, 2. Now, just so you know, when I did this myself, and luckily I was able to erase it and go back and record over, I had a different answer, but when I did the check on the video, it showed that it was not the right answer, because in my equation, when I came over to this second part, I had plugged in a -3 and gotten a whole different answer. Because I checked it, I caught that that was the wrong answer, went back and figured out that the -1, 2 works. So it's really important that you do check that. So then here we come down to this last one, so some more writing equations. Definitely not an easy thing to do with these systems. We're going to keep just giving you them as we go, and hopefully they'll start to make a little sense. So we have too much information in here. We have Drama Club is earning a lot of money. We have 64 adults, 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. Write the system first. So let's talk about this. So let's call, and we started to draw a little bit of this here for you. So let's call the adult ticket the X. Let's call the student ticket the Y. So kind of understanding and defining your variables is an important thing, so that later on you'll have an idea of what your answer should be once these X's and Y's come out. So the first equation that you can see right here, we know that there are 64 adult tickets sold. We don't know the ticket price for those adults. We know that 132 are sold. We don't know their price for the students. We do know there's a total number of dollars of the 1,040. So by putting that first equation together, this equation is referring to kind of like the money part of our system. Okay. The second one, we talk about the total number of tickets and how they compare to each other. So we're looking at this one next, and we're looking at the adult ticket price is 2 times a student ticket, and that's what we see right here. So an adult ticket is worth a student ticket times 2. So that second equation is the adult ticket price, which we said was X, is 2 times the student ticket price, which is the Y. So there would be the first part of my answer. Write a system of linear equations. Now we want to solve what is the price of each ticket type. So then we now have 2 equations. Think of your steps. The first one said have one of the equations solved for one of the variables. The first 2 examples we did were solve for Y's. But notice this time we have this one right here, solve for X's. We can use that. There's nothing wrong with using that. So we're going to kind of focus on that second equation now. So X is worth 2Y. So what we're going to do this time is, instead of plugging it into the Y for the first one, this one is X's are worth that. So we're going to replace it for the X on the one above it. So our new kind of substituted equation is going to be 64 times 2Y plus 132Y equals 1,040. So we've taken the X out and replaced it with the 2Y. And again, the big thing on this is, now that I've created this joint combined equation, there should only be one variable. This time I see Y's and Y's. If somehow I plugged it in the wrong spot and saw X's and Y's, you need to go back because something's not right. So let's keep solving. So now we got to get all of our Y's combined. I have 128Y plus 132Y equals 1,040. We then can combine these two to get, let me change that. I started to write 100, but it's definitely not 100. It is 260Y And then we would just have to divide by 260. 1040 divided by 260 is 40. So that would tell me that the Y value, which we said was our student ticket price, is $40 a student. So then what we have to do is figure out, well, what's the adult price? So again, I can plug this Y equals 40 into one of the original equations. I think it should be clear looking at your two equations which one is easier. I think the x equals 2y from above is way easier to do than the first one. You can pick it if you want, but I'm going to go the easiest way I can. And I'm going to plug in this as 2y, and that means $80 for the x. So again, in a word problem, we want to make sure that we are giving our accurate answers with our labels attached. So we are going to say $40 per student ticket and $80 per adult ticket. We'll keep working on creating these word problem systems. They are challenging, and the more you practice them, the better you get at them. Hopefully this method makes some sense, and we'll be practicing them this week in school. It's definitely a good method to use. It's more algebraic, so you can just focus on the equations. But if you have any kind of questions, please make sure you speak up and ask so that we can help get you through it. And then we're going to show you a third method to solve these systems in an upcoming lesson.